So yesterday, if you were here, which most of you were, we worked on factoring the difference of two squares, and we did some normal ones like you might have seen earlier in your mathematical life. Then we got a little tougher. So real quick, in case somebody was gone, I'm going to go x squared minus 9, and this is actually like an Algebra 1 level, so none of us are concerned about this. That's a square, that's a minus, that's a square, and it becomes x plus 3 and x minus 3, and that is not supposed to be difficult at this level. So if you've been here, that's not difficult. If you just got here, that's what happened yesterday. So I want to look at a question, and I want you to have your calculators handy too. Also. And I'm going to write down this problem. P to the fourth minus 256. And most of you were not remaining standing when we were doing our squares yesterday, when you got about 169, 196. Most of you were sitting by then. Not all of you, but most of you were sitting by that time. Would you please use your calculator and see if 256 happens to be a perfect square? Most of you didn't get that high, so use your calculator. Is in fact 256 a perfect square? Say yes or no.
Yes.
It is a perfect square. And by the way, p to the fourth, let's look this way. P to the second times p to the second. Remember, you add the exponents, is p to the fourth. So is p to the fourth a square? Yes, p to the second times p to the second. So we've got square minus square, which we should be able to write something down. And I'm going to look out the window for 8 seconds. Will you write down what that is? You wrote down p squared plus 16, p squared minus 16. Say, I sure did.
I sure did.
Excellent. Now don't write this down, but I'm going to go back to elementary school for a minute. And people at home just deal with it. And we were doing a factor shrub back in elementary school. And you did 5 times 4. You made 20 into 5 times 4. And you know what the teacher did? How come? Why did the teacher mark that wrong in elementary school? The teacher did mark this wrong in elementary school. Is this what you're thinking? How many were thinking this and just didn't say it? Does 4 become 2 and 2? In elementary school, did you have to go that far? Yes. Cool. Would you look back here? If you walk away right here, I'm marking it wrong. Oh, how mean could that be? Not really. Is this a square? Is that a minus? Oh, so that one can't go any further. That's going to stay just like this. Is that a square? Is that a minus? Is that a square? Ah. Do you have to do that? The answer is yes. You have to take that as far as it possibly can. Very cool, very cool, very cool. Good, good, good. This is still from yesterday. All right. Drive these people over here. They'll have fun. What's the theme for your get-together this weekend? Maybe watching math videos might be your theme for the weekend. All right, how about give this one a try, please, from yesterday. Whoops. Is 2 a square? One times 1 is 1. 2 times 2 is 4. Do you think that the teacher put the second problem of the day as a prime? The teacher did not. It's not prime. With finger signals, tell me what number you're like putting out front. Does 2 go into both of those? Say yep.
Yep.
Cool. Nobody got as high as 625. It might be a square. Please, on your calculator, see if 625 is a square. It is. It is. It's the two must come along. A squared plus 25. A squared minus 25. I believe that's the same basic problem that we had just 2 minutes ago. We have one more step to do. And those of you that were here yesterday, I told you that we will have some topics that seem like Algebra 2 topics that we might take one step further, and that might have happened. All right, here's today's new material. I'm about to write the word sum and difference of 2 cubes. I'm about to write sum and difference of 2 cubes. You might be writing ahead of me. I think I hear some noise out there. I do. Everyone turn around and out loud say, "Hi, Whitney."
Hi, Whitney.
Hi, Whitney. Anyone here will take that mail for you. Just reach your hand out there and you can get it. Well, thank you very much. Thank you. Thank you. No, you can keep that mail there. You can read it for me. Excellent. Well, thank you, Whitney. You having a good day? Do you like the rain? Cool. All right, Whitney. Everyone out loud say, "See you later, Whitney."
See you later, Whitney.
All right, bye. All right. Good job, Whitney, with the mail. Thank you. Okay. Cool. So now we're back to the sum or difference of 2 cubes. All right, and there's 2 formulas which I did not, if you got to this in your Algebra 2 class, I did not have you memorize this. You will be memorizing this, please, and you won't be writing it on your hand or your desk or cheating. By the time we test, I think, which is next Tuesday, so we're still like a week away. And I'm going to actually show you a way that it's not too difficult to remember. I'll tell it now. I'll tell it many times. But when it's the plus problem, the first one's a plus, and you just remember the other one's different. So first one's obviously a plus, and then the middle one's a minus. When it's a minus, the middle one's a plus. We'll work more on memorizing soon. All right. Some of you are in a mode of not believing me. I don't believe you, some people are thinking. Well, I'm going to say the word that starts with that fancy letter, P. It's a geometry word that was loved by all. Pro. Prove. Proof. Oh, there's a word that is, if you people could see the joy on their faces when I said proof. Oh my goodness. Happiest part of your schooling was proofs? Yep. I'm going to prove the following. I'm going to prove that a cubed plus b cubed truly is a plus b, a squared minus ab plus b squared. But I'm not going to prove it in the geometry way with the 2 columns. Oh, we want 2 column proofs. I'm going to do the following. I am simply going to multiply and show you that it really works. So I take a times a is a cubed A times the middle is minus a squared b, and ab squared. Now I'm going to take b times everything, b times a squared, so that's a squared b, and I'm taking that minus ab squared, and b times b squared is b cubed. Cool. And you will notice that that plus that is nothing, and that minus that is nothing, and all that is left is a cubed plus b cubed. So for those of you that don't cheat come test time, and if you go, oh, did I write it down correctly? Did I remember it correctly? You could do this. You could multiply it, and if it comes out to this, you did remember it correctly. However, we'll practice so many times memorizing that you probably will eventually get it memorized. So what happens when you've got a cubed plus a cubed? We have a special formula. When you have a cubed minus a cubed, we have a special formula. And how about with your calculators, have them handy. We're not going to stand up and do this in our brain. We're going to write down some cubes. And I'm just going to write down the first three, and then we can get it work on our calculator. 1 times 1 times 1 is 1. 2 is 8. How about 3 cubed?
27.
All right, we're going to go up to about 7. We can either use your brains or your calculator. So now I'm looking at 4 times 4 times 4, which happens to be 64. How about 5 cubed?
125.
125. And we have 6 cubed yet?
116.
Not quite.
So 216, sorry.
6 cubed is? 216, and 7 cubed is? Anyone got it?
343.
Yeah. So there's a bunch of the cubes. It's not all of the cubes, but it's a bunch of the cubes. By the way, if you're looking for the cubed root, depending on your calculator, if you have a TI-8384, you've got your math button. It's right below your colorful button. Press math, and then about the 4th option down is a cubed root. You might see that there. If you have another calculator, there certainly will be some kind of option for the cubed root. Do I have to stop yet? I have to stop soon. Here's a few more cubes. X cubed is a cubed. X times X times X. Now, I'm looking at the next variable cube. I'm going to go the same thing times the same thing times the same thing. So I'm doing x squared times x squared times x squared. If you'll remember, when you're multiplying numbers to the common base, you add the exponents. You add the 2, the 2, the 2, you get to the x to the 6th. Anyone who wants to know why? It's because that's xx, that's xx, that's xx, 1, 2, 3, 4, 5, 6. So x to the 6th is a cubed. Here's the next cubed. x3 times x3 times x3. We add the exponent as x to the 9th. And in fact, we have a little pattern. All of these, in fact, are cubes. And that ends the first part of today's video recording.